Good evening, I'm Rachel Maddow. Thanks for being here. Tonight, we're taking a step back from the sensationalism that often surrounds military footage online and looking instead at the reality behind one of the most technically demanding roles on the modern battlefield: long-range marksmanship. When we see soldiers moving under pressure or taking cover, it's easy to focus on the drama. But behind every moment are years of training, discipline, communication, and scientific precision. So let's reframe the conversation not around spectacle, but around the extraordinary complexity and professionalism that defines this field. The challenge of engaging moving targets. Engaging a moving target in a conflict zone is far more complex than many people assume. While striking a stationary object is largely a matter of stable position and controlled breathing, a moving individual introduces variables that change from second to second direction: speed, elevation, and unpredictable shifts in path. In many training scenarios, soldiers are taught that movement is their ally because it forces the opposing side to constantly readjust their calculations. Even when individuals pause briefly to climb an obstacle, cross terrain, or coordinate with their unit, those moments require high awareness from both parties. For marksmen, the decision to act or not act is influenced not only by their technical ability, but also by the tactical situation, nearby structures, weather elements, and communication with observers who monitor the broader environment. This reinforces how every engagement is less about split-second reaction and more about carefully reading the situation in real time. Why distance matters in precision shooting. Modern long-range shooting relies heavily on an understanding of distance, and the further the target, the more unpredictable the world becomes. At shorter ranges, around a few hundred meters, an experienced marksman can reliably place shots on relatively small objects, even in modest wind. However, once distances stretch beyond several hundred meters, the situation changes dramatically. At distances of 800 to 1,000 meters, for example, the margin for error becomes extremely thin. The curvature of the bullet's arc becomes more pronounced, the air density begins to play a larger role, and even slight changes in temperature can create noticeable shifts in trajectory. Military training across the world emphasizes practicing at varying ranges to understand how different conditions affect accuracy. When nations such as Germany, Ukraine, the United States, and others conduct precision shooting drills, they do so to study these physical effects and prepare marksmen for real-world scenarios where every environmental factor matters. The complexity of hitting moving vehicles. Hitting a moving vehicle is an entirely different scientific problem. Unlike a person moving unpredictably on foot, a vehicle introduces consistent speed but often covers distances faster than a marksman can safely adjust. Because vehicles move across multiple planes, forward motion, bumps in the terrain, engine vibration, and acceleration predicting exactly where they will be several hundred meters away is extremely challenging. In training environments, even highly skilled marksmen find it difficult to strike targets in vehicles unless the vehicle is slowing, turning, or navigating an obstacle that forces a brief pause. Motorcycles, for example, present unique challenges. Riders lean their bodies, shift weight, and adjust balance, making their movements more irregular than on a car or armored vehicle. Studying such scenarios allows military instructors to teach the limits of marksmanship and highlight the importance of not relying solely on aim, but rather on structure, timing, and environment. Camouflage and the art of not being seen. Camouflage is one of the most underrated elements of long-range engagements. A highly trained marksman can remain hidden in plain sight thanks to color matching, shadow awareness, silhouette disruption, and terrain blending. Instructors often challenge students with exercises where a sniper is hidden somewhere in a photograph or field, and identifying them becomes nearly impossible even when you know one is present. The ability to remain unseen is not simply about wearing patterned fabric. It involves using natural textures, staying completely motionless for extended periods, and choosing angles where the human body's outline blends with its surroundings. This requires immense patience and mental control, When observers review footage from conflict zones and struggle to identify where a shot originated, it demonstrates that camouflage is functioning exactly as intended. The role of drones in modern military strategy. Modern conflicts increasingly rely on drones for reconnaissance, communication, and situational support. While earlier generations of military operations depended heavily on forward observers risking exposure to gather information, drones now allow teams to assess terrain, monitor movement, and avoid unnecessary harm. They serve as an extra set of eyes in the sky, guiding ground units and helping decision-makers evaluate when it is safe to proceed or when caution is required. In many documented cases, drones provide confirmation after a mission, support search and rescue, track environmental hazards, and reduce the risk to personnel. Their growing presence shows how technology is reshaping how modern militaries operate, shifting the focus toward information and precision rather than force. A record-breaking shot. The achievement of Vyacheslav Kowalski. Among the most remarkable achievements in the history of precision shooting is that of Vyacheslav Kowalski, a 8-year-old Ukrainian marksman who reportedly executed a record-breaking long-range shot at 3.7 kilometers. Regardless of national affiliation, age, or background, such an achievement is objectively extraordinary from a scientific and technical standpoint. To understand its difficulty, imagine the length of 2 Brooklyn bridges placed end to end and the bullet still traveling farther. With a flight time of nearly 9 seconds, the projectile had to withstand wind, air resistance, gravitational drop, and countless micro variations in atmosphere. What makes the achievement notable is not harm, but human capability. The mastery of physics, teamwork, judgment, and discipline under pressure. It highlights how rigorous training and scientific understanding can push the limits of what was previously thought possible. The science behind ultra-long-range shooting. Ultra-long-range shooting is essentially applied physics. Every shot over extreme distances is influenced by gravity, wind, temperature, atmospheric pressure, and even humidity. Gravity causes the bullet to drop in an arc, forcing marksmen to aim higher than the target to compensate for the descent. Wind can shift the projectile left or right, and even slight gusts can create large deviations at long distances. Air density, influenced by altitude and temperature, affects how quickly the bullet slows down. One of the least understood but very real factors is the Coriolis effect, caused by Earth's rotation. While it has minimal effect at short ranges, at multi-kilometer distances, it becomes measurable enough that skilled observers must include it in their calculations. Ultra-long-range shooting, therefore, is not about instinct. It is about performing real-time calculations that resemble scientific equations more than traditional marksmanship. The observer, the unsung mastermind behind every shot. Popular media often portrays snipers as lone geniuses making impossibly precise shots. In reality, long-range shooting is conducted by a 2-person team, the shooter and the observer. The observer is typically the more experienced of the two. Equipped with advanced binoculars, rangefinders, weather meters, and deep knowledge of ballistics, the observer calculates wind drift, bullet drop, angle corrections, and environmental influences. They relay precise adjustments to the shooter, who then focuses on executing the shot with perfect stability and timing. In training, observers are responsible not only for calculations, but also for situational awareness, monitoring surroundings, watching for movement, and ensuring that the team does not lose concealment. Their expertise transforms a complex puzzle of environmental factors into a clear set of instructions. Without observers, long-range shots, especially record-breaking ones, would be nearly impossible. Why exact distance is essential. Accurate distance measurement is one of the most critical components of precision shooting. The longer a bullet stays in the air, the more it drops due to gravity. A miscalculation of even a few meters at long distances can result in significant inaccuracy. To solve this problem, observers use laser rangefinders, which send a narrow, invisible pulse of light to a target and measure how long it takes to return. Military-grade rangefinders can measure distances of tens of kilometers with impressive precision. This allows marksmen to adjust elevation settings on their scopes with remarkable accuracy. Without the correct distance, no amount of skill or talent can compensate for the inevitable gravitational drop that every projectile experiences. Understanding this fundamental principle reveals how much modern precision shooting relies not on guesswork, but on technological support and scientific discipline. How wind shapes a shot. Wind is one of the most unpredictable variables in long-range shooting. It can change direction or intensity between the shooter and the target, meaning that a perfect reading at the firing position may not reflect conditions hundreds or thousands of meters away. Observers use handheld anemometers to measure wind speed, but they also rely heavily on visual cues, like waving grass, leaves, dust, mirage patterns in heat waves, and the movement of smoke or fog. The wind can push a bullet several meters off target at extreme distances, making wind correction one of the most challenging aspects of the job. Because of this, marksmen often train for years to develop an intuitive sense for how wind affects bullets at various ranges, combining scientific readings with experienced judgment. The Coriolis effect. When Earth's rotation matters, the Coriolis effect is often misunderstood, but it plays a real role in extreme distance shooting. Because Earth rotates from west to east, objects moving long distances appear to drift sideways relative to the surface. In the northern hemisphere, this drift appears to the right, in the southern hemisphere, to the left. While the effect is extremely small at close range, at distances of multiple kilometers, it becomes measurable. Marksmen do not feel this effect. Instead, observers calculate it using ballistic tables or digital tools. This illustrates how far precision shooting has evolved. It is no longer just about marksmanship, but about applying knowledge from physics, meteorology, and even astronomy. The mental discipline behind the shot. Beyond physical and scientific challenges, long-range shooting requires intense mental discipline. Marksmen may wait for hours or even days for the right conditions to align. They must remain perfectly still, maintain situational awareness, stay calm under pressure, and trust the observer's calculations. A single rush decision can compromise the mission or reveal their position. This psychological component is often overlooked, yet it is arguably the most important element separating trained professionals from unprepared shooters. Patience, resilience, and emotional control are as essential as technical skill. Conclusion: snipers as scientists of the battlefield. When viewed through a non-sensational lens, snipers are not merely individuals with steady aim, they are scientists of the battlefield. Every shot they take is the final step in a chain of complex calculations involving physics, mathematics, environmental science, communication, and psychology. Their work requires discipline, careful coordination, and respect for the consequences of their decisions. By understanding the science and teamwork behind long-range shooting, we gain a deeper appreciation not for conflict, but for human skill under demanding conditions. If this exploration of precision shooting and military science enriched your understanding, feel free to support further content by liking, subscribing, and sharing your thoughts below. Your engagement helps bring more educational discussions like this to the forefront.